Alright, so in this problem, I have 4 to the power of x is equal to 8. So obviously here, I want to find the value of x. So for my solution, first start by rewriting my problem. So I have 4 to the power of x is equal to 8. Now 4 here, this is the same thing as 2 squared. So I'm going to rewrite this as 2 squared to the power of x. All I did was replace 4 with 2 squared. And now 8, this is the same thing as 2 to the power of 3. So I'm going to replace 8 with 2 to the power of 3. So I have 2 squared to the power of x is equal to 2 to the power of 3. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is simply 2 to the power of 2x. And now this is equal to 2 to the power of 3. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. Meaning, in this case, 2x is equal to m and 3 is n. So I have 2x is equal to 3. And this is a simple equation. All I have to do is divide both sides by 2. So then these two cancel out, and I get x is equal to 3 over 2. Alright, so in this problem, I have x to the power of x plus 1 is equal to x. So to solve this, I'm going to start by subtracting x on both sides. So then these two cancel out, and I'm left with x to the power of x plus 1 minus x is equal to 0. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of x plus 1, this is going to be equal to x to the power of x times x to the power of 1. Now I have this minus x is equal to 0. Now if I factor out x, I get x times x to the power of x minus 1 is equal to 0. So now this gives me two equations. I have x is equal to 0, and I have x to the power of x minus 1 is equal to 0. So x equals 0. This is already a solution. Now for x to the power of x minus 1 equals 0, I'm going to add 1 on both sides. So then these two cancel out, and I get x to the power of x is equal to 1. Now, because x has to be the same number, we obviously know that, well, what number to the power of itself is equal to 1? That's going to be 1, right? Because 1 to the power of 1 is equal to itself. So x is equal to 1. And there's no other number that when you take the power of itself is going to equal 1. Meaning x equals 1 is the only solution to this equation. So now to check, the original equation was x to the power of x plus 1 is equal to x. So x to the power of x plus 1 is equal to x. And our first solution is 0. So if I plug in 0, I get 0 to the power of 0 plus 1 is equal to 0. Now 0 plus 1 is 1, so I have 0 to the power of 1 equals 0, and 0 to the power of any number is itself, so I get 0 equals 0. Now to check for 1, I get 1 to the power of 1 plus 1 is equal to 1. 1 plus 1 is 2, so I get 1 to the power of 2 is equal to 1, and 1 to the power of any number itself, so 1 equals 1. Alright, so in this problem, I have x to the power of x is equal to 100. So I'm going to first start by taking the natural log, or ln, on both sides. So I have ln x to the power of x is equal to ln 100. Now, if I have something in the form ln a to the power of b, I can move this x1 and b to the front. So this is going to equal b times ln a. So for ln x to the power of x, I can move x to the front, and I'm going to get x times ln x is equal to ln 100. Now ln 100, that's the same thing as ln of 10 squared. So I get x times ln x is equal to ln 10 squared. And if I have something in the form ln a to the power of b, again, I can move 2 to the front, so I get x times ln x is equal to 2 times ln 10. Now, there's something called the W-Lambert function. And if I take the W-Lambert function of something in the form a times e to the power of a, this is going to equal a. So this is basically what the W-Lambert function is. So if there's something in the form a times e to the power of a, that's going to equal a. So what I'm going to do over here is I'm going to rewrite x here as e to the power of ln of x, because the e and ln cancel out, and this results in simply x. So I'm just going to rewrite x as e to the power of ln x, and I have this times ln x is equal to 2 times ln 10. And now this is in the form a times e to the power of a. So now if I take the W-Lambert function on both sides, this results in ln x equaling w of 2 times ln 10. And now if I take e to the power of both sides, I get e to the power of ln x is equal to e to the power of w of 2 ln 10. And e to the power of ln x, that's going to equal x. So I get x is equal to e to the power of w of 2 times ln 10. And this is equal to 3.597285, which rounds up to 3.597. So this is my answer to this problem. Alright, so in this video, I'm going to solve the equation x to the power of x to the power of 4 is equal to 64. So the variable I want to find the value to in this equation is x. And for my solution, I'm going to first start by taking the power of 4 on both sides. So I get x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. However, m and n are interchangeable, meaning this can also be written as a to the power of n times m. Now, if a to the power of m times n is equal to a to the power of m to the power of n, then a to the power of n times m, this should be equal to a to the power of n to the power of m. So x to the power of x to the power of 4 to the power of 4. In this, I can think of x to the power of 4 as m and 4 as n. So this turns into x to the power of 4 to the power of x to the power of 4 is equal to 64 to the power of 4. Now 64 to the power of 4 I can rewrite as 8 squared to the power of 4, which turns into 8 to the power of 8. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a equals b. So in this case, x to the power of 4 is equal to 8. And to solve for x, I'm going to take the fourth root on both sides. So I get x is equal to positive or negative fourth root of 8.